Welcome to math, first lesson of our last unit of the year. It's been a good year. Guys been working real hard. Today you're going to use the data in a table to write an equation for a function and use the equation to find a missing value. We did something very similar earlier this year, so this should be a nice review of how to look for patterns and be able to write some sort of equation that can show that pattern consistently. Here's your warm-up. So what I want you to do for this is solve them. Now remember, this gives you what x is, so they shouldn't be too hard. You just got to drop that number in for x and solve for it. Come back when you're ready. We'll see if you can figure out the right answer for all these expressions. All right, so here are the answers you should have received. I put the value above the letter, and you can see for number 1, you had to do 4 times 2 first. Minus 1 is 7. Number 2, it's 7 times 5, which is 35, plus 3 is 38. Number 3, it's 1/2 times negative 6. Well, that gives you negative 3 plus 2, negative 1. And then for number 4, it's negative 2 times 8, which is negative 16. Minus 3 makes it even more negative, negative 19. All right, today we're going to work on the rules of functions. So what is a function? Well, hopefully write this down. Function is a rule that relates to two quantities, so two values, so that each input value corresponds exactly with the output value. So what you put into your problem will give you a value that is appropriate when it goes out. Input, output. All right, so we're looking for these patterns here, input and output. So you think of the x as the input and the y as the output. So really all we're doing is we're trying to figure out how can we solve this box here, solve for this box, and how can we find some sort of equation that's going to be written, that's going to be consistent every single time. So we got to start looking for patterns. Well, if we look down here at the y's, we can see that we're going from 13 to 16, 16 to 19, 19 to 22, 22 to 25. You've probably already noticed that it seems that there seems to be a pattern of plus 3 every time. So with that pattern of plus 3, we know that 3 is going to somehow come into play within our equation. Okay? But we have to see how from x to y works as well. Well, if I look at x and I figure out how can I get from 3 to 13, I'm looking for the quickest pattern to get to 13. Now I know 3 times something will get us faster to 13, but it won't get us to 13. So if we first try to get as close as we can, 3 times what gets us close to 13? Well, 3 times 4 can get us to 12. And if we add 1, that gets us to 13. Well, now I'm looking at that and going, yeah, that could work, but it has to work every single time. And I think we're going to run into a problem here if we try to continue to do that every single time, if we do times 4 plus 1 with the next one. So 4 times 4 gives us 16 plus 1. Now we're over. So remember, I looked before we started looking at the multiplying that there might be a number that comes into play, and because we saw a pattern of 3's down here, plus 3, plus 3, plus 3, plus 3, let's see if we multiply 3 times 3, if that helps. Well, 3 times 3 gives us 9, right? So from here then, we're going to have to add what to get to 13? That would be 4. 10, 11, 12, 13. Now, let's see if we do the same thing with number 4. 4 times 3 gives us 12. And if we add 4, that gets us 16. Okay, so let's see if we can continue that pattern again. If we use the input of 5 for x, 5 times 3 again gives us 15. And if we add 4, we get 19. All right. So we found a pattern here that works to get us from the input. If we input x into something, we're going to get y. So if I was to write our equation over here, it would be x, anytime you see x, no matter what it is, times 3 plus 4. is going to equal y. So our way of checking this, we've already seen that if you input x, 3 for x, if you input 4 for x, and you input 5 for x, we get the corresponding y correct every time. So if that works, what we need to do is we need to check it to make sure that we find out what we get if we use 10 as our input. So let's just plug 10 in for x and see what we get. So 10 times 3 plus 4, is that going to equal y? Well, y is a number that we're trying to figure out. 10 times 3 is going to get us there, which is 30 plus 4 equals y. 30 plus 4 gives us 34. So our equation that we're using is y equals 3x plus 4. That's going to be our pattern. And we're able to check it to see if it works. Now, how can we actually check to see if this math works? Take what you have for y and reverse the work. I'll show you what I mean. You can check your work if we just use the same formula, 3x plus 4 equals, this time, let's put 34 over here. Okay? So now we can reverse to get x alone. So we have plus 4, which means we have to subtract 4 from both sides. And now we're left with 3x equaling 30. Well, what do we do to get x alone here? It's multiplying, so the inverse of multiplying is dividing. And we can divide by 3 on both sides. 3 goes into 30 10 times. And if x equals 10, which it does, we know that it works. So once you find the one input, you can do it back and forth to see if you get the right answer. Let's get this written down so that you can show that you know how to do these. All right, I want you to try these two on your own. But if you want a little extra help, I will do number 1. So pause the video if you don't want to see me doing number 1. All right, so let's first start with number 1. We're looking for a pattern. And it kind of looks like from here, we're going 7 to 8 if x is 1 to 2. 2 to 3, 8 to 9. So it looks like everything's kind of going up by 1. So this one will probably be a little simpler. Let's see how quick we can get from the input of x to y with this problem. Well, if we just multiplied x times what we see in y, we might get a result. So what if we do 1 times 7? Okay, that gets us 7. But what if we do 2 times 7? Is that going to get us 8? Nope. So that's not going to work. So let's try to go back down and see if we can make it a little quicker. I bet if we tried a little bit of multiplying and then adding, we're going to have some trouble here. When I think it's pretty simple to see what can we add by. 1 plus what gets us 7? Well, that would be 6. Okay, let's see if that works the second time. 2 plus 6. Well, that gives us 8, so that seems to be working. What if we did 3 plus 6? That gets us 9. So now we've already found our equation. All you have to do is take x and add 6 to it, and that's how you're going to equal y every time. So that's part of our answer that we need to write down, but now we need to solve if we put 9 as our input. So what if we had 9 plus 6? What's that going to equal? That's going to equal 15. So y equals 15. That shows us that we know our function and we know what y equals. Now, go ahead and try to solve the next one on your own and come back. All right, so for number 2, I started looking at how to get as quick as I could from 3 to 16. And I saw that if I did 3 times 5, that gets me close to 16. Add 1, I get 16. So I tried the same thing on the second one. I did 4 this time times 5. And that got me 20 plus 1 is 21. So I followed the pattern. The input is 5 times x plus 1. That's going to give you y. So what I did, and that's the word so, it looks like 50. It should say so. When I drop 10 in for x, 5 times 10 is 50, plus 1 is 51. So y would be 51. So if you had the same equations as I did, and the same values, and those that tried number 1 on your own, that's what you should have got over there. Give yourself a pat on the back. All right, so in example 2 here, we're going to look at how sometimes you'll get words written, and you have to be able to describe how to solve things with words, translating words. Well, in our example here that I'm going to do with you, it says write an equation for a function. Tell what each variable you use represents. So if we're looking at this, it says the height of a painting is 7 times its width. Well, first we got to choose the variables. We obviously know we're trying to find the height, so I would use h, and you can see right here that I use h for height of painting. The width, I use the w for width of painting. There's one other thing that's in here, and it says 7. Well, it also says 7 times its width. So we know that it means that the height equals 7 times its width. So we need to do 7 times what we use as a variable here, which is w. So 7 times w is going to give us our height. So this is the equation that we're looking to write. That's all you have to do here is write the equation. So go ahead and write this down before moving on. All right, so here are 2 problems you're going to try on your own. Remember, first, write down what the variables are going to be, and then go ahead and try to solve or create an equation using your variables. Now, for those that want a little extra help, I'm going to go through number 1. If you think you can do this on your own, pause the video at this point. So number 7 says the cost of a case of bottled juices is $2 less than the cost of 12 individual bottles. Well, the first thing I see is cost of case. So I'm going to say C equals cost of case. Okay. The second thing I see in here is that we need to know what the cost of a bottle is. And the cost of a bottle, I can do, I'm going to say B. B equals cost of bottle. Now from here, I just have to look at the numbers we have available and see what we're going to do. Well, the output of this is that we're going to need to figure out what the cost of a case is. So C equals. And from here then, we have to look at what we have. Well, the one thing I see is we have $2 less than the cost of individual bottles. So remember, we said B is the cost of bottles. So there's 12 bottles, right? So we're going to do 12 times B. And then it says that a bottle is $2 less than, the case is $2 less, so minus 2. So that's how you come up with the answer of C equals 12 times B minus 2. You're going to have to figure out what the cost is for an entire case and then just subtract $2. Now, go ahead and try number 8 on your own. Look for your variables and what you can label them, and then write out your equation. And for number 8, here's the answer I have for number 8. It says the population of New York is twice as large as the population of Michigan. So basically, we have to multiply Michigan by 2, because that's twice. So I used N for New York as my variable and M for Michigan. So 2 times Michigan equals New York, or 2M equals N, or N equals 2M. Those are the answers you should have had there. And finally, let's talk a little bit about word problems. So sometimes you're going to have to pull all that information out and actually solve for something, not just write an equation. So here, this example says, the school choir tracked the number of tickets sold and the total money received. They sold each ticket for the same price, so everyone had to pay the same amount. They received $80 for 20 tickets, $88 for 22 tickets, and $108 for 27 tickets. We got to write an equation to figure out this function. So first we have to understand what we're looking at here. Well, we know that we're going to have to write an equation to describe a relationship. So we have to take the information we see here and pull it out. So my plan is simply to make a table based off the information we had. So I'm going to use T for tickets, and I used M for money. So it said in the problem, for every 20 tickets, you got $80. For 22 tickets, it was $88. 27 tickets, $108. So really what we got to do is find out what is the pattern of getting from T to M. Well, when you look at this, to get from 20 to 80, how many times do you multiply 20 to get 80? 20, 40, 60, 80, 4 times. So let's see if we just multiply each one by 4. 22 times 4 gets us 88. 27 times 4 gets us 108. So we found our variable. To get M, which is our output, M equals whatever T is times 4, or 4T. So that's our answer. So that's what you have to do for these problems is set up a table. Usually helps if it's going to give you a continuation of info. So here's one for you to try. It says Brenda sells balloon bouquets. She charges the same price for each balloon in a bouquet. The cost for a bouquet with 6 balloons, $3. If you have 9 balloons, $4.50. If you got 12 balloons, $6. So write an equation. Again, like I just showed you in the example, I would write out a box, a table, and I would come up with 2 variables that you're trying to solve for. Go ahead and try it on your own and then come back. I'll show you how I did it. All right, so here's the answer that I got for my problem. I made B the cost of the balloons, or the bouquet of balloons, and C equal the cost. So B was how many balloons, C was the cost. So I noticed if I spent $3, I got 6 balloons, $4.59 balloons, $6, 12 balloons. I was doubling it. I was multiplying by 2. So basically I wrote B equals, so the balloons or the bouquet equals 2 times the cost. So for every dollar I basically spent times 2 is how many balloons I got. So that was pretty easy for me to figure out. Now, I could figure this out and say, okay, I could use this equation for later if I wanted to and said, what if I wanted 24 balloons? What would that cost me? All I have to do is I have to put in 24 for B and figure out what's the cost. 2 times what gets me 24, which is 12. So I'd have to spend $12 to get 24 balloons. All right, it's thinking time for you. I want you to go ahead and answer this box of thought before doing the quiz. Explain how you'd find the value of y when you know that the x value is 20 for a function of y equals 5x. How would you solve that? You can solve it, but tell me the steps that you would do. All right, and here's your quiz. 2 questions. First, write an equation for the function that you see here. So solve by using your input x to write an equation for equaling y. And then number 2 is write an equation for the function of the following. Tell what each variable you use represents the height of a round can that is 2 times its radius. You should be able to figure that out by now. All right. We'll see you when you bring me your answers.